Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, type of distillation process. Now, in that most type of distillation process, we are discussing extractive distillation mainly and difference between extractive distillation and azeotropic distillation. Now, there are various types of distillation process. They are popularly used in various industries separating different products that are fractional distillation, extractive distillation, reactive distillation, simple distillation, steam distillation, vacuum distillation, air sensitive vacuum distillation, salt pulp distillation, zone distillation, azeotropic distillation, distillation under reduced pressure, destructive distillation, and industrial distillation. When the physical property, mainly boiling point, of the component in a mixture are very close to one another, example azeotropic mixture, the separation method become difficult. Out of above type, fractional, extractive, reactive, and industrial distillation are more frequently used ones. Now, we are talking about extractive distillation. What is that? Extractive distillation is defined as distillation in presence of miscible, high boiling, relatively non-volatile component, the solvent that form no azeotrope with other component in the mixture. The method used for mixture having low value of relative volatility nearing unity, such mixture cannot be separated by simple distillation because the volatility of the two components in the mixture is nearly same, causing them evaporate at nearly same temperature at similar rate, making normal distillation impractical. The method extractive distillation uses separation solvent, which is generally non-volatile, has a high boiling point and miscible with the mixture, but doesn't form azeotrope mixture. The solvent interact different with the component of the mixture, thereby causing their relative volatility to change. The enable the three-part mixture separated by normal distillation, the original component with the greatest volatility separate out top product. The bottom product consists mixture, solvent and other component which again separate easily because the solvent does not form azeotrope with it. The bottom product can be separated by any of the method available. It is important to select a suitable separation solvent for type of distillation. Solvent must be relative volatility by wide enough margin of a successful result. The quantity, cost and availability solvent should be considered. Solvent should be easily separable from bottom product and should be react chemically with the component or mixture or causes corrosion equipment. The classic example cited here separation, the azeotrope mixture of benzene and cyclohexane where aniline is one of the suitable solvents. Now, system example. Component mixture, low relative volatility and those contain azeotrope. They are good candidate of extractive distillation. Using example consider system consisting toluene, boiling point 110.8 degrees centigrade and isooctane, boiling point 99.3 degrees centigrade, all through separation difficult. Convectional distillation process, extractive distillation prove the successful addition, phenol, boiling point 181.4 degrees centigrade solvent. In practical, toluene and isooctane separate from non-ideal liquid solution with phenol. Consequently, when all substances are combined, toluene and isooctane themselves behave non-ideal mixture, the relative volatility become high and isooctane is recovered the distilled product with toluene phenol mixture recovered the bottom product. This mixture is further separated by solvent recovery column where toluene is distilled away phenol. Finally, phenol is recycled back to first column. Now, application of extractive distillation. Extractive distillation prove useful many different fields include but not limited pharmaceutical, chemical, petrochemical, refining industries. One of the major applications of extractive distillation, petrochemical and refining industries is the recovery aromatic hydrocarbon. Advanced solvent technology increases the feasibility and profitability of the using extractive distillation, resulting benefit such low capital cost, lower risk product contamination with solvent carryover and high product recovery and purity. As a result, industries carry out extractive distillation process, recovery, pyrogenic gases, byproducts such as benzene, toluene, and xylene, means BTX, from naphtha base, steam cracker, and the desulfurization of the fluid catalytic cracking gasoline, styrene recovery of the pyrolysis of the gasoline. Now, pharmaceuticals, especially chemical industries, extractive distillation further play an important role. Wastewater treatment. Example, isopropyl alcohol, one of the most widely used manufactured pharmaceuticals, can be obtained. Isopropyl alcohol oblique water mixture, top product of the extractive distillation column after addition ethylene glycol. The recovery of solvent, isopropyl alcohol, may have many benefits, include waste reduction, cost saving, and straight Environment Protection Act requirement of the wastewater disposal. Now, extractive distillation, powerful tool, separate close boiling mixture or azeotropic mixture. It can make easier solvent in liquid phase and require less processing versus azeotropic distillation. The solvent must be condensed before return the initial column. Additional extractive distillation can be much more cost effective and pressure swing distillation. Ultimately, extractive distillation not for all difficult distillation separation, but it should always evaluate of the options. Now, choice of solvent should be enhanced significant natural relative volatility and key component should not require excessive ratio of solvent non-solvent because of cost handling column auxiliary equipment should remain soluble feed component and should not lead the formation two phase should be easily separated from the bottom product should be inexpensive readily available should be stable temperature distillation and solvent separation should be non-reactive component in the feed mixture should have low latent heat should have non-corrosive and non-toxic. Now, basic difference between extractive and azeotropic distillation. First, in azeotropic distillation, it is chemical technique used to separate component from the mixture by formation of an azeotrope, while extractive distillation is a technique addition of third component binary mixture will separate two initial components. In azeotropic distillation, third component add is referred entrainer, while in extractive distillation, third component add referred solvent. Product obtained azeotropic distillation from bottom of the column, while in extractive distillation column, product is obtained from top of the product. Now, azeotropic distillation and extractive distillation, both methods use chemical engineering to separate azeotropic mixture. They are mixture of liquid have constant boiling point and cannot separate simple distillation. In azeotropic distillation, entrainer or third component add to mixture break the azeotrope. The entrainer form new azeotrope when one of component original mixture allow separation of the desired component. In extractive distillation, the solvent add the mixture to alter the relative volatility component, making easier separate them. The solvent form separate liquid phase with one of the component. Extractive changing the overall composition of mixture allows separation. In the summary, azeotropic distillation realize the addition, entrainment, and from a new azeotrope, while extractive distillation involve addition solvent to alter the relative volatility component. Both the methods are used separate azeotropic mixture in chemical process. The key difference between azeotropic and extractive distillation. In azeotropic distillation, the formation azeotrope is required to separate component mixture, where extractive distillation, no azeotrope formation takes place. The distillation process, purifying liquid by process of heating and cooling, and azeotropic distillation. The azeotrope is formed prior separation of the component from a mixture. Azeotrope is a mixture component having a constant boiling point. In extractive distillation process, there are no need form an azeotrope. In that method, third component add binary mixture. This third component can affect volatility existing component. Now, again further, we are go for the difference of azeotropic and extractive distillation. What is that? That is azeotrope distillation separation technique used to separate component mixture by forming an azeotrope. Extractive distillation separation technique that include addition third component binary mixture permit to separation the two components. In azeotrope distillation technique, the formation of azeotrope prior to the distillation is important. In extractive distillation technique, non-volatile component add to the mixture can affect the volatility component in the mixture. Azeotropic distillation separate component into vapor phase which has same chemical composition in liquid phase. Extractive distillation separate component of a matrix of the substance. Now both process involve the addition new material, solvent and mixture. The solvent choose increases relative volatility component to separate azeotrope distillation. The process distillation where you can add certain component mixture. Better separation process. The certain component add mixture water or benzene because of help the increases volatility of the substance. Azeotrope distillation accomplishes addition liquid phase and volatile third component entrainer which changes volatility one of the two components more than other, so components are separate by distillation. Extractive distillation technique where the capability of the miscibility the component being non-volatile and even a high boiling point could be measurement separating mixture without even forming azeotrope. The kind of method used to mixture almost same volatility, otherwise volatility different, small that adequate separation cannot be made. The possible increases volatility difference by addition extraneous material can be separated later. This process known extractive distillation add material relatively non-volatile and leave column of the residue. In the case of the extractive distillation, however, function the material, extractive agent and simply solvent. The different solvent need to vaporize. In case azeotropic distillation, there are problems separating component product, but the extractive distillation problem much simpler. Normally, quite high boiling beyond the range of azeotrope formation and simple distillation sufficient separate the solvent rescue and because of low volatility withdrawal the product and bottom less solvent is required. Used to solvent the highest relative volatility always give lowest total annual cost and extractive distillation process. In azeotropic distillation the solvent withdrawal azeotrope with one or more component separated usually overhead product. The main difference between two, the process separate the mixture azeotrope distillation from azeotrope. Right after combining separation solvent, the azeotrope can combine a way separating the mixture because it cannot be easily changed. Just a simple distillation. The extractive distillation, the specific separation solvent is used every mixture that should not form azeotrope. In way, extractive distillation is a better and easier method, the azeotropic distillation. But you need bear in mind you have a mixture with very different volatility and most effective separation method will be azeotrope distillation. Okay guys, this is up to this topic type of distillation process in that mostly we cover extractive distillation and azeotrope distillation. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topic. Still then goodbye, do care yourself.